Hey guys, welcome to the first lesson in Unit 2. We're going to talk about something called relations and functions. Now, this is review from Algebra 1 when you were in Chapter 4, but it's actually one of the most foundational topics to Algebra 1, so I definitely want to go over it again as a basis for the rest of Algebra 2. So we're going to start by breaking it down into what parts we're going to look at. And the first thing we're going to talk about is, well, what do you mean, Mrs. Langeli, when you talk about a relation? What definition should I understand? Well, a relation is simply a set of ordered pairs. The first one's going to be the domain, and the second one's going to be the range. Now, this word domain and this word range should ring a bell from Algebra 1. So you can have different types of relations. Let's look at these examples. This particular relation is really just a list of ordered pairs. No rhyme or reason. In fact, this one almost seems to be out of order, but it's just a list of ordered pairs you could plot on a coordinate plane. Now let's look at the second type of relation. The second type of relation is a mapping diagram. These should have been discussed in Algebra 1, but also they might have been forgotten. So a mapping diagram is just a different version of ordered pairs. So for example, it always has to start on the left, go to the right, and use an arrowhead that points at the right. That represents the point 1B. Let's take a look at this one. This would start at 2, go to C, and this would represent the point 2C. So it's still just a list of ordered pairs. And I want you to notice that this side needs to be in order, and this side needs to also be in order from least to greatest. And the arrowheads must point to the range. Start at the domain and go to the range. This will be a quiz question. Kids get it wrong simply because sometimes they pick the one where the arrowheads aren't. Question on quiz. They'll pick the arrowheads that aren't pointing in the right direction. So remember, they must point to the right, and they have to go in order least to greatest. Now, a relation could also be identified as simply a graph. Like this is a graph of something called a parabola. So this is, again, it's just another type of relation that sets each x with a y. So let's take a look. For example, here you go. So really just a set of ordered pairs. Like this one is 2, 4, right? So it's just a culmination of a ton of tiny little points. And in case you need more clarification on what a mapping diagram is, here's the definition of a mapping diagram. All right, part 2. Let's talk about review. What is a domain? What is a range of a relation? So the domain are the input values. So domain goes with input values. And then range, down here I put the definition, range goes with output values. I would suggest pausing the video and reading through those definitions. Take a minute to do that, and then I'll come on back. Hopefully you took the time to do that. In Algebra 1, the domain were typically the x values as long as we're using x and y, and the range were also the y values as long as we're using x and y, not some other variables. So I wanted to go over here and list the domain in order. This would have been a keystone question you would have had in Algebra 1 on the keystones. You do need to list them in order with no repeats. So let's see how you guys do with that. If you want to pause the video, you can, but I'll show you on domain how it starts if that helps. When in Algebra 1, when I have my general Algebra 1 students, I always have to put an X over those. Oops, sorry about that. And a Y underneath these. That way they don't lose anything. And we're going to go in order. So the smallest X, and I'm going to build up on my X's. There they are. I'll highlight them. I did 1, 2, 4, 6, 8. And I'm going to do the same thing for my ranges. I'm going to start with the smallest range. Let's see, where's the smallest range? 3. And then what's my next smallest range? Sometimes these are harder to find. A 5. Now I have 5 twice. I am not going to write 5 twice. You never repeat. You just say, hey, my range includes a value of 5. So you actually kind of did both of those by writing a single 5. Do not put repeats. And then 7 and 9. And whatever you want to do, make sure you know that it has to be in order with no repeats. And that's how you list your domain and range. These are unique single points, so we write them like that. Number 2, we do the same thing in here when we list our domain and range. Remember, it has to be in order, least to greatest, no repeats. So it's 1, 2, 3, and 4. And then in order, least to greatest, A, B, C, and D. Those are braces. Nobody in Algebra 1 ever likes to write them. I picture it like a letter C, then a V, and then a C. So I've just done them a whole bunch in my career. So it's CVZ. That's how I make a brace. All right, and it lists your domain. It kind of keeps them in a set. And then number 3, the domain and the range are a little more limited. Now, let's go ahead and assume that these have arrowheads on them. Please do that for me. Pretend those have arrowheads on them and this graph continued forever. This one's probably going to be a little harder to remember since it is going left forever and right forever. You would say that your domain is all real numbers like that. You would say X is all real numbers because it goes on and on. There's no stop. Now your range, on the other hand, your range does have a bottom. You like look at your y-axis, right? This is your y-axis. See how it doesn't go under 0? Like there's nothing underneath of here. So we say range is y is greater than or equal to 0 because it's everything above 0. So again, just a very quick flashback to Algebra 1. I will review that later on the lesson as well because I do realize that this is a very difficult concept to remember from Algebra 1. Okay, part 3, functions. Now, a function is a special type of relation, just like a girl is a special type of human. It's like a category. Some are functions, some are not functions. But I want to say, what would make a relation into a function? And hopefully you don't have things muted because I'd like to talk about relationships in general. You know, I have a husband, Mr. Langeli, and we are in a relationship, right? Well, our relationship will only function if I'm his only wife. So I know that sounds really weird, but I'm hoping it helps because let's look at this definition. It says a relation becomes a function when each element in the domain, like my husband, is paired with exactly one element in the range, me. If my husband had 2 wives, we would not be functioning very well. So I always kind of like picture it like that. If you're in a functioning relationship, your buddy, your significant other really should only have one other significant other. So every input should only have one output. Hopefully that's helpful for you. And you can use a vertical line test, and I'll show you that with number 3. So let's take a look at this example. Again, the ordered pairs. So I want you to look at all the x's. I want you to look at the 1, the 2, the 4, the 6, and the 8. 1 is only paired with 5. 2 is only paired with 3. 4 is only paired with 5. 6 is only paired with 7. 8 is only paired with 9. If you had 6, 2, that would be really bad because 6 is already paired with 7. So this would not, if that was there, that would not be a function. However, my original relation, that's good. My relationship there is yes, it is a function because every x has one and only one y value, or each input has one and only one output. Now let's look at this mapping. I went and I found another mapping. One of these is a function and one of them is not. So you see how this domain only points once, this only points once, this only points once, this only points once. This one is a function. But can you see how this one down here, see this 3, how it points twice? That's bad. Okay, this one is not a function. So it says which one is a function? This one over here. It's okay if this letter B, if that output has a double, that's okay. But an input cannot have a double. All right, so output having a double is okay. Input having a double is bad. So the first one is a function. Number 3, now, wow, okay, if I say which x has one and only one y, that might be difficult. But if we use something called the vertical line test you learned about in Algebra 1, you can see which graph is or isn't a function. So we did it for points, we did it for mapping diagrams, now we're going to do it for a graph. So I'm going to take this vertical line, okay, I'm going to use Notability there, I'm going to make a vertical line, I'm going to grab my swoopy tool right there, I'm going to move my vertical line through, okay? So you can see that this vertical line only touches once. You can see that if I move it here, it still only touches once. You can see that if I move it here, it still only touches the graph or the relation once. Now I'm going to move it over here. Now, when I put it right here, you can say, hey, it only touches once there. 100% I agree with you. But now let's take our vertical line and let's move it here. See how it touches the relation or the graph twice? That automatically means no, it's not a function. it's not a function if it touches twice, which means this one was a yes because every x only had one y. This time, this x value has two y values, so it's no good. That's not good. So that one's not a function. Now let's move it right here. Well, right here, the x has only a single y value, but what about anywhere inside of here? Like here, we'll go where they have their line. See how there's two y values for this x value? That means it is not a function. So if it fails in one point, it fails. It's not a function. All right, so I said which ones are functions? Just that one. That's the only one. This one's the only one that's a function. I love the vertical line test. It's such a good visual. I think I did an okay job explaining it, but there is, especially for those of you who are my readers, there's your technical definition. All right. Good news is I really can count. This was part 3. This should have said part 4, but I'll fix it on yours before I post it. So I apologize. Part 4, function rule and function notation. In Algebra 2, function notation is a way to represent functions in a more concise and standardized form. Now, people hate function notation. Function notation makes students very sad. In fact, dare I say, sometimes in Algebra 1, we as your teachers avoid it, which is not a good thing. So I'm going to make a choice in Algebra 1 and maybe do a better job with that. Typically, function notation is f of x. This is not f times x. Just so you know, it's a function based on x. F is simply the name of the function, x is the input, and f of x represents the entire output. Okay, so f of x, I have a poster in my room. It's orange. I have a poster that says f of x is a fancy way of simply writing, oh, does writing have one T? I think so. I don't know. Why? Now I feel silly. I need to Google it. Oh, it's a good thing I teach math. Yep, it's just one T. F of x is just a fancy way of writing y. So don't picture f of x as two variables. It's really just a single output variable of y. Okay, number 1. So I have an example here, and this example is going to use the function rule. A function rule is just like an equation, okay? Function rule is equation. Function rule is equation. That was discussed in Algebra 1, but I'm not going to assume that you totally remember that. Let's say that f of x equals 2x plus 3, and it represents a linear function where for any input x, the output is 2x plus 3. Okay, so now it says solve for f of x when x is negative 4. So what I'm going to do, I'm going to use this quick little, actually I'll just rewrite it. It's f of x equals 2x plus 3, that's the function rule. They want me to replace x with negative 4. This is just a statement. This is not multiplying or anything. That's just saying, what is my function at negative 4? What is my function at negative 4? So that's going to be negative 8 plus 3 is negative 5. So the answer is negative 5. If you want to write it as an ordered pair, remember you would write the x value first, negative 4, and the answer we got, negative 5. Now I am going to make it more difficult for you. This is still the same exact function rule, but now look at how the directions change. Solve for x if f of x is negative 4. So I'm going to do f of x. I'm just going to write my function rule. All right, so linear function rule. You're going to put negative 4 in for the variable f of x. You replace all of f of x. So all of f of x gets replaced with negative 4. And now we have to do some easy Algebra 1 where we take something to the other side, divide by 2, and I guess I can show you on the calculator. Fractions are going to be your friend in Algebra 2, so I would like you to make sure you know how the calculator works if you're not good at them, okay? So negative 7 divided by 2, math, enter, enter, is negative 7 over 2. So if we write that as an ordered pair, we have an input of negative 7 over 2 to result in an output of negative 4. Now it's time to apply this to a word problem. And this would be part 5. I will fix that on your notes. Okay, don't worry, I can count. Taylor Swift is planning a new concert tour. She has a budget for stage design, lighting, and special effects. The total budget for these elements is $500,000. So that's her budget. She wants to allocate $30,000 per concert for these expenses, and she needs to spend $50,000 on a one-time initial setup for the stage design that will be used throughout the entire tour. How many concerts can Taylor Swift afford to hold within her budget? So I want to show you something, a little trick. When you see the word per, the word that follows that is going to usually be your X. So it says, let X represent the number of concerts that she can have. The total cost for the concerts can be expressed as an equation. Now, I kept this linear for you. This would have been a problem you would have seen in Algebra 1. You see this total cost here? I know her total cost includes the $30,000 per concert. And that's how you write this, guys. This is really just y equals mx plus b, slope-intercept. When you hear the word per, that's going to go there. And I use an asterisk with that, but it's typically your slope, unless the problem's written kind of silly. So it says $30,000 per concert, so that's where the 3x came in. And you see this initial setup fee? This is usually going to be your y equals mx plus b. That one-time setup fee is going to be your y-intercept, the $50,000 in the back. And again, if you're like, boy, how'd you do that, Miss Langeli? Well, that's Algebra 1. All right, so if that's something you're struggling with, we definitely need to sit down and work that out together. So the total cost, and, oh, look what we did next. So instead of writing the word total cost, we wrote it in what's called function notation. This is the cost, and it is based on the concerts. So this is really just y equals. All right, so we're going to drag this down. So there's my equation. And now we answer the question. We know that she has a budget that is a total cost of $500,000. So that needs to go in either for X or it goes in for C of X. So remember, X was how many concerts she had, right? See up here, X was how many concerts. So if we put 500,000 in for X, we're saying she's going to have 500,000 concerts. No way. That's not a thing. Okay? It's going to be her cost. So when we have C of X equals 30,000 X plus 50,000. This number that we're given to solve for, that goes in on the Y side, or the independent side. Excuse me, the dependent side. So everything else stays the same. And now we use our good Algebra 1 skills to solve. So minus 50,000. And I'm thinking a lot of you are okay without showing that particular step. I'm hoping we can kind of skip that in your work for the majority. 450,000. And divide, right? Showing my work for you because it's been a whole summer. I understand. For some of you, it's been, what, a year and a half because of geometry, right, in between there. There you go. So 15 is X. With word problems, I'm going to let you know you should have a statement. All right, so here's your statement. If you had me in General Algebra 1, you remember statements are very important because it shows that you actually understand what you did. So 15 was how many concerts she could have to stay within her budget of $500,000. So it's really important that you follow those steps. You have to know what X stands for, you have to know what your Y side stands for, and you have to be able to solve appropriately. All right, I did everything conceptually that you need to be able to get through the practice problems. The only thing you need to do now is you do need to go and watch the next video about domains and ranges. Quite frankly, this is one of the students' worst recollections from Algebra 1. So please go to the next video, solve this out. Hopefully you'll get a feel for domain and range and get you warmed back up again. Have a great day, and we'll see you soon.